Okay, hello everyone. Welcome to Master the Codes, and this is the third video for the graph series. And today we are going to talk about breadth first search, which is a very important concept in graphs and is quite commonly used. So, if you haven't watched the previous two videos, please do not forget to watch them. They are quite intuitive and informative if you want to learn about graphs. This particular playlist is for all those who are gonna crack interviews, who want to learn data structures, or have learned and are yet to mastering it. So this particular playlist is for all those. And please like, share, comment, and subscribe to the channel for more such related content. Now, without further wait, let us get started. So, this time we are talking about graphs, right? We know graphs are a non-linear data structure, which has been explained in the previous video. And this time we are going to talk about traversals. That is mean how we want to traverse the graph, how we want to search a particular node. And the most important thing is the breadth for search. It is a very important algorithm that is used almost in every questions in graph and has been asked multiple times by Amazon, Google, Facebook, or the FANG companies. If you are dealing with graphs, they always begin with the breadth for search and then they add complexity into the question. So if I create a graph like this and assign various nodes and edges, now you all know that these are edges which were explained in the previous video, and these are nodes n1 and n2. So in breadth first search, what happens, we take a particular node. Let's say we have taken this node n1 or node 1, and from this node we check all the neighbors, like the neighbors are 2 and 3. Then we check the neighbors of 2 and we go for the neighbors of 3. Then we go for neighbors of 4, and so on and so forth. So it is mostly, you can say, like a traversal algorithm which moves forward step by step. It is not like it will reach. If I draw another graph like this, in DFS what happens, it traverses an entire branch once and then it goes to the next branch. But in DFS it traverses a node breadthwise, right? It will first traverse this level, then it will go to this level, and then to the last nodes. That is how BFS works. Now, coming to the algorithm, in the previous video itself, I have explained you how the BFS works. And let us take an example this time and see how the algorithm will work in this particular case. So let me quickly draw a graph. This is node 1, this is node 2, node 3, node 4. I'm drawing a bit of a complex graph so that it becomes easy for you all to understand and visualize how the algorithm works. This is node 8, right? So the first thing is I need to create a visited array, and the array should be of size same as that of the graph. So currently all the nodes are marked as false, right? There, this is your visited array. This is your visited array, and currently all the nodes are marked as false, that is, they are not visited. Then we will enter the source node into the queue. So for that we need to create a queue as well. I have created a queue, let's say, and the node which I am taking is 1. Okay, as the source node. So I will enter 1 over here, right? And when I am entering 1 over here, I will mark this particular as true. the visited array, that I have visited this node. I do not need to visit it again. I have visited it, right? So then in the next step, I will check all the neighbors of the node. So if you see, if I draw the adjacency list of the graph, 1 is connected to 2 and 5. 2 is connected to 1, 6 and 3. 3 is connected to 2 and 4. 5 is connected to 1 and 6. 4 is connected to 3. 6 is connected to 2, 5, 7 and 8. 7 is connected to 6 and 8 is also connected to 6. This is what I would call my adjacency list. And if you don't know what is an adjacency list, please check out my first video of the graph series, right? And that you will get to know what is an adjacency list and how you can create an adjacency list of a graph. So the first thing is we need to create the adjacency list. That would be step 0. Then step 1 would be create a visited array. Then in step 2, I will enter the source node into the queue. So I need to create a queue as well, right? I need to create the queue as well. I have created the queue and I will enter the source node into the queue. Now I will check all the neighbors of the node. The neighbors of queue are 1, you can look over here, 2 and 5, right? And at the same time, I will check if neighbor is not visited, add it into the queue. And you can see for, let me give it indexing as well so it becomes a bit easy. 1, 2, 3, 4, 5, 6, 7 and 8, right? As you can see, node 2 and node 5, they are not visited, so I will add them into the queue and remove 1. So I will add 2 and 5 and I will mark it as true, and 5 also I will mark it as true. Then I will go into node 2. Yes, this is the queue again. From node 2, I will check all the, you can say, neighbors. That is 1, 6 and 3. And you can see 1 is already visited, so I will not add it into the queue. This one, this is already visited, so I will not add. I will add node 6 and node 3, which are not visited. So queue will become, the 2 will get removed and I will add it after 5. I will add it over here, right? Node 3 will be added and node 6 will be added. Okay. Now I will go to 5. 5 has 2, you can say, neighbors. That is 1 and another one is 6. And you can see 1 and 6 are already visited. 1 and 6 are already visited. So I will not add them. I will simply terminate the 5 and keep the queue as it is, 3 and 6. Now I will go to 3. 3 has 2 neighbors, 2 and 4. 2 is already visited. I will not add it into queue. I will add 4 into the queue and mark it as visited. And that 4 I will add it after 6 at the endpoint. Then this in the queue. Now I will go for 6. 6 has 4 neighbors, 2, 5, 7 and 8. You can see 2 and 5 are already visited, so I just need to add 7 and 8. 4, 7 and 8. Now I will check for 4. 4 has a neighbor 3 that is visited. I will just remove 4 and keep 7 and 8 in the queue. And similarly, 7 has one neighbor, that is 6, that is visited. I will keep only 8 in the queue, and 8 has only one neighbor, that is 6, and when I will pop the 8, the queue will become empty, right? And when the queue becomes empty, our algorithm stops, right? So that is how a BFS works. I'll tell you again. You need to create a visited array. You need to create a visited array of size n, or sometimes even n plus 1 if you are taking a 1 based indexing. Enter source node into the queue. Check all neighbors of the node, like as you have checked in the visited array, and that you will do using the visited array. And if the neighbor is not visited, add it into the queue, and this entire process, these two, will be repeated till the queue becomes empty. So that is how this is how the algorithm works, right? Now moving on to the applications, like where you can apply the queue. And before that, please like, share and subscribe to the channel. I will also be providing these notes in the link, as well as the code and my profile for the GitHub. I will be providing all these three things in the video, in the below description. So please like, share and subscribe to the channel to keep me motivated for creating more such content. Now, coming back to the topic, what are the applications? Now, where all you can use, you can count the number of nodes using this. You can count the diameter. Now, what is diameter? If you have a graph like this, and I am saying taking these two nodes, then the number of nodes or the path of the node from reaching this point to this point, that is termed as the diameter, which is 3. This is termed as the path. This is termed as the path, and the largest path becomes the diameter. Or we can use it to count the depth of the tree and perform greedy calculations. Now, what are greedy calculations? In which you do not simply use either sorting or a min-max function to find the best answer. Right? So that is how you do it. Either you go through sorting or use a min-max operation to find the best answer, and that is immediate. Like the immediate, I'll tell you what is immediate and optimal answers in the questions when we would be doing the questions, but for now, that is how the breadth first search works. And let's move to the code of this breadth first search. It is going to be quite simple and quite easy, because in queue you just need to perform these three operations, that is add to add the elements, poll to get the first element, just only these two, and to check if it is empty or not, there is a function called isEmpty. Using these three functions, you will be able to perform the BFS in the queue. Now we will move to the second part of the video, that is creation of, or rather implementation of code for BFS. Okay, so here is the code. This first line is for taking the inputs. These two are for taking the number of nodes and the number of edges in the graph. Remember, these two things will always be given to you in the question. So you do not need to worry like what would be the size of the graph, how many edges and how many nodes would be there. These two things will always be given. And similarly, I'm creating using this graph as the name of the variable to create the adjacency list. If you don't know about adjacency list, I have provided the link of the video in the description down below and in the top right corner as well. Currently, you can click on it and get to know what is an adjacency list and how to create it. Because in every question of graph, you need to create an adjacency list. Then I'm creating it. This particular thing is quite important in terms of if you're working in Java. Otherwise, it would assign every value or rather every neighbor as null. So to eradicate that possibility, I'm using predefining it as an array list, okay, rather as a list. Now I'm filling all the values in the edges, extracting node 1 and node 2, right? These functions are similar, just I'm adding the values like getting the key, getting the node. If I get node 1 and adding the neighbor of 1, and similarly, if I'm adding 2, I'm adding the neighbor of 2, and then I will perform the BFS. Now, here is the code of BFS. As I have told you, I created the queue, right? I created the queue of type integer. Why I've created of type integer? Because I have taken the nodes of type integer. Then I have added the source node as the first step. I have created the visited array of size n plus 1 because of one-based indexing. And I'm running this code until the queue becomes empty, right? Now, these are the print statements. No need to worry about these. Now, this is the important part. It is used to perform static updation. Now, what do I mean by static updation? If you do not write this, if you simply use I equals to 0, I less than q dot size directly over here, it would be dynamic allocation. Like every time q gets dynamically updated, it will add some nodes, it will remove some nodes, so size will vary for every operation. To keep that size static, right? For every bit to keep that size static, I'm using this. So it is an important line or important piece of code that you have to write definitely. Then I'm using the poll operation to pop the first element or rather extract the first element of the queue from the head. I'm marking it as visited or rather true. Then checking every neighbor of the current node. If the node is 1, I'm checking every neighbor of 1, that is 2 and 5, right? 2 and 5. And if that neighbor is not visited, if that neighbor is not visited even once, I'll add that neighbor into the queue and mark it as visited. The logic which we just understood a few minutes before. And then it is just the print statement. So if you see, this was the graph that I wanted to draw, that we drew, right? Just a minute. And if you run the algorithm, it would work the same way as expected. If this is the input, now what you must be thinking, what are these? These are nothing but just the input variables that I'm taking, because since I'm taking string as the input to differentiate between the two nodes, I have used the split function. Now, what do I mean by this? Firstly, I'm taking here input as the string, then I'm splitting it on the basis of white space to split it between the first node and the second node, as you can see over here. That is the logic which I'm using, nothing else. And if you copy the test case and run the code, you will see the required output. Like first node 1 will be added, then we will go to node 2 and node 5, node 2 and node 5, then I will go to node 3 and node 6, and then I would go to node 4, 7 and 8. That is how the operation works. And if you are thinking of a much better possibility or a much better output, you can simply remove it. Remove these print statements as well and simply write it over here. System.out.println or other print node, and if you run it, you will get the required output as wanted. 1, 1, 82536 and 478. So that was BFS, which we discussed just now. Everyone, please like, share, subscribe to the channel, and I will be providing more content. And the next video we were gonna talk about DFS. I will be providing this code and the notes in the description down below. Please don't forget to share and subscribe to the channel and hit the bell icon for more notifications. Thank you very much for watching the video, and we'll meet soon in the next video. Until then, bye bye.